এই অভ্র দাদা, কি আগে আগে এসে বসে আছো তুমি? এগুলো তো ঠিক না। অভ্র, ভাই আপনি কই থেকে? আপনি এরকম আগে আগে বসেছেন কেন? এই যে আগে আগে বসে থাকার কাজ আমার, আপনার না। আপনি এই কাজ করবেন না এরপর থেকে। নেক্সট টাইম। ও আচ্ছা 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 আচ্ছা, না বুঝতে পারছি, ঠিক আছে, সমস্যা নাই। ওকে, মেইল করছেন? মেইল মেইল শোনেন, বোঝাপড়া করেন কিন্তু খুবই কনফিডেন্সিয়াল জিনিসগুলো, খুবই কনফিডেন্স। আচ্ছা, রেকর্ডিং চালু নাই তো? ঠিক আছে, নাই। জিনিসগুলো খুবই কনফিডেন্সিয়াল, যত কম শেয়ার করবেন তত ভালো, বুঝছেন? হ্যাঁ সেটাই, যত কম শেয়ার করবেন ততই আপনারও মঙ্গল, আমারও মঙ্গল, শাওনেরও মঙ্গল, ম্যাডামেরও মঙ্গল। ঠিক আছে। ঠিক আছে, বোঝাপড়া করেন, কোনো সমস্যা নাই। ঠিক আছে, বাদ বাকিটা ম্যামের হাতে, তারপরে উপরে তো আরেকজন আছে, তার হাতে তো সবকিছু। ঠিক আছে। এই জন্য আমি আমি কল আসছে নাকি আপনার? নাকি আমার? আমাকে তারেক কাছে তুষার কল দিচ্ছে, কিরকমটা লাগে? মেসেঞ্জার আছে, দেখে কি বলে। অব্র ভাই, অব্র। হ্যাঁ ভাই, কি অবস্থা? এই তো, আরে পাগলা বুঝেন না, পাগলা এখন কালকের ম্যাথ করার জন্য পাগল হয়ে গেছে। আইটেন এর বই থেকে করবো নাকি কিসের বই থেকে করবো, নাকি স্লাইড থেকে করবো? এই পাগলারে না তারা থাকেন কেমন, আমি এই বুঝি না। এই আমার রুমে ছিল আমার সাথে চতুর্থ পঞ্চম ষষ্ঠ সবগুলা ওয়ার্ল্ডের, আমার ওর সাথেই হইতো। না, ওটা তো আমি জানি। ঠিক আছে, ওটা তো আমি জানি, কম বেশি আমি তো শুনি শাওনের কাছে। কেন ছিলাম না? প্রজেক্টের সময় তো ছিলামই, দেখছি তো কাহিনী দুই চারটা কিছু। ও আচ্ছা আচ্ছা। না না, প্রজেক্টের সময় তো আমরা কাজ করতাম, ও তো ঘুমাই যেত। তখন তো দেখছি উল্টা পাল্টা ও চলে যেত, প্যারানর্মাল জগতে চলে। দু একদিন করছে, প্যারানর্মাল জগতে চলে গেছিল, যাই হোক। আচ্ছা, তোদের কি কোর্সটা করাবে না, এই যে অ্যাপ্রিসিয়েশনে যে মডেলিং এর যে কোর্সটা আমরা করলাম? হুম হুম হুম। মানে তার মানে তো ফোর্থে আমরা আরাম করবো, তোরা প্রেসারে থাকবি। একটু বেশি প্যারা খাবি, আমার তো 17 ক্রেডিট, তোদের মনে হয় বেশি ক্রেডিট নাকি? ভালো ভালো। না, তোদের তো মেবি আসবেও না, মনে কর যে তিনটা টিমও করে দেয়, তিনটা মডেল আসবে হয়তো বা, 10 জন করে হলেও। একটা একটা, হ্যাঁ, ওইরকম তিনটা মডেলই যাবে। দুইটা দিতে পারে। না, তিনটা দিবে, 10 জন 10 জন করে যদি দেয়। আমাদের তো মেবি কয়জন ছিল? না, 10। হুম। 7 জন 7 জন, কারণ আমরাই তো 7 জন করলাম না, আমরাই তো যখন করছি আমরা তো 7 জন করছি। হ্যাঁ, তোদের তোদের রুমে তিনটা, আমার রুমে চারটা, 7টা। হ্যাঁ ঠিক আছে, অমনি আসবে দেখিস। আরে প্যারা নাই, প্যারা, প্যারা। হ্যাঁ অবশ্যই অবশ্যই, ঠিক অবশ্যই। আমরা ওয়েট করতেছি। হ্যাঁ, আর হেল্প লাগবে না। আর এইসব মানে, মানে এক্সট্রাঅর্ডিনারি মানুষদের হেল্প করতেও লজ্জা লাগে মাঝে মধ্যে। ঠিক আছে, অপমান কে কারে করে। যাই হোক, সেই মেজর থেকে একদিন আসবো, বের হইস। এই ওষুধ ওষুধ নিতে আসতে হবে তো আবার, নতুন রাউন্ড 2। রাউন্ড 1 তো প্রায় শেষের দিকে, এখন রাউন্ড 2। ঠিক আছে। তখন হ্যাঁ, আলহামদুলিল্লাহ, ভালো 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 ভালো, ওষুধের প্রভাবে কোনো সমস্যা হয়নি। Okay. ঠিক আছে, তাহলে ড্যাডি আসুক, আমরা ওয়েট করি। এই বাগদার ডন সারেক। সারেক,
বল,
কি রে
খাইতাছি।
খাইতাছস? খাইতেই থাক আর আজীবন।
ভাই ক্ষুধা লাগছে প্রচুর।
প্রচুর ক্ষুধা লাগছে না? রবিউলের কথা শুনে বেটা মাথা মতো হ্যাং হয়ে গেছে গা, আর কস তুই তোর কাছে ক্ষুধা লাগছে। আমি তো এবারও কালকে ওই দিনে পরীক্ষা দিতে পারবো না।
কোনটা, রবিউলের?
হম।
কি করবো ক, পরীক্ষাটা না দিলে ভালো হয়। সবাই মিলে যদি এই ডিসিশন হয় যে না দেয় তাহলে ভালো।
না দেওয়ার ডিসিশন কেন ভাই? হ্যাঁ টাইম বাড়ে, তার সমস্যাটা কি ভাই?
এটাই বাড়াই মনে রে ভাই, কতবার কইছে দেখছিস না?
এদের মইনুল স্যারে কিন্তু কিচ্ছু কয় নাই, মইনুল স্যার কিন্তু কত ভালো লোক না দেখ।
হুম। আমি খালি পা ধরা বাকি রাখছি।
থ্যাংক ইউ শারেক, থ্যাংক ইউ, থ্যাংক ইউ। আচ্ছা খা খা খায়।
Alright.
হ্যালো।
Hey, look, who is here? সজল।
আমি তো ক্লাস করি ভাই।
তুমি কে ভাই? ক্লাস করো?
ক্লাস করি না, আমি একদিনও ক্লাস মিস দিছি, আমি করোনা নিয়েও ক্লাস করছি।
ওয়াও। সারেক তো আরো এপিক, ভাত খাইতে খাইতে ক্লাস করে। ও এখন ভাত খাচ্ছে।
ও ভাই
জিজ্ঞেস
ওটা
করবি?
ক্লাস করি।
তুষার চলে আস, তুষার। তুষার ম্যাথ করা শুরু করে দিছস এনভায়রনমেন্ট এখনই?
আচ্ছা, এনভায়রনমেন্টে কি ম্যাথ আছে?
তুষারে জিজ্ঞেস কর।
পুরাটাই ম্যাথ।
তুষার আমার একটু আগে ফোন দিয়ে কয় ম্যাথ কইতে করবো।
পুরাটাই ম্যাথ রে ভাই, কেমনে কি সম্ভব না এগুলো?
পুরাটাই ম্যাথ।
ইউটিউবে
আর
দেখ,
দুইটা স্লাইডে ম্যাথ আছে।
টপিক দেখে দেখে ইউটিউবের তে ম্যাথ কর, বানায় বানায়।
মজা লস আরে, দেখাইস।
হ্যাঁ আমি সিরিয়াস, অনেক সিরিয়াস আমি।
আচ্ছা, আজমাইন জিজ্ঞেস। অব্র অব্র ও খাইতেছে মনে হয়।
অভ্র নাই, অনেকেই এখানে নাই, ওর জয়েন্টে চলে গেছে।
আহ,
এই সজল, কালকে
হ্যাঁ।
মনে আছে রাতের বেলা রুমমেট ভাই?
ও মাই গড, আবার মনে করে
ভাই
দিলি।
আমার মানিজ্জত ওই জায়গায় ইনস্ট্যান্ট শেষ।
এটা
কেম
কেমনে বলছে ভাই?
ভাই এটা কেমনে? এটা তো ভুলেও এটা বলার কথা না।
তুই চিন্তা কর, ওর মানে আরেকজন কি মনে করছে তাইলে?
আরেকজন কি ভাই, পুরো সামনে পুরা মনে করি যে এতগুলা পোলাপান ফট করে করে বলাইছে রুমমেট।
এই হায়াত আছো নাকি?
তুষার, তোর কথায় তো রেসপন্স করে না তোর ইয়া কি বলে-
আরে হায়াত লজ্জা পাইতেছে ওটা।
তাই
হ্যাঁ হ্যাঁ, মানুষের সাথে কথা বলতে লজ্জা পায় হায়াত।
দেখ ও মনে
তবে
হয় ঘুমাই যাচ্ছে।
তবে স্যারদের আবার ভয় পায় না, স্যারদের আবার ধমক মেরে পড়ে।
দেখ ও ঘুমাইতেছে মনে হয়।
তুমি হায়াতে চিনোই না তুষার, বুঝছো?
হায়াত
আরে
কিন্তু
বাবা,
পড়া দেয় ঠিকই, আবার পড়া দেয় ঠিকই।
হায়াত হাইপার হয়ে যাবো রে ভাই। বুঝলাম না আজকে রবিউল স্যারের সাথে হায়াত হাইপার হলো না কেন? কি কারণটা কি? নাকি হায়াতের
কারণ
মাইনর
হায়াত সব
মেজর?
পারে স্ট্রাকচার, ওর হাইপার
আরে না
ওর
না,
কিছু।
ওর মেজর মাইনর কোনোটাই স্ট্রাকচার নাই, এই জন্য হাইপার হয় নাই।
আমারও তো নেই।
ওই ওই ম্যাডামেরটা কিন্তু হয়েছিল, এনভায়রনমেন্টে হাইপার হয়েছিল হায়াতে।
Good afternoon.
গুড আফটারনুন স্যার।
So, up to previous day, we discussed. Can you recall from your memory? Can you recall from your memory what we discussed after previous day? We discussed about the water resources, its necessity of irrigation, advantages of irrigation, disadvantages of irrigation, and then types of irrigation, methods or techniques of irrigation. Okay, there are 7 methods or techniques, and in that chapter we also discuss about the quality of irrigation water and related to this. So this was the contents of basically the chapter number 1. Then in chapter number 2, we discussed about the water requirements of crops. We discussed duty delta, water requirement at different periods of a growing crop. And we set up the relationship between duty and delta. And we saw that duty at different situation and different position. And also we discussed something related to improving the duty, how we can improve the duty. We discussed about the seasons of the crops, different types of crops, Rabi Kharif ratio, and optimum utilization of the then definition of a consumptive use. factors and how to measure this conjunctive use. We discussed different methods, practical and also some empirical formulas. Are you getting me or not? Then we discussed about the effective rainfall, different types of irrigation requirements, and depending on this irrigation requirement, different types of efficiency of application of water in the fields. And we did some problems, and we talk about the gravitational water, capillary water, hygroscopic water that is available water. And then we set up the relationship between field capacity and how much water can be extracted from the soil by the roots of the plants for their nourishment, when to fill the water once again to the fields, so that the growth of the crops cannot be hampered. How many days, after how many days, what will be the cycle for applying irrigation water to the field? All those we discussed, and related to that, we did one or two problems in the class. So this is the basic. These are the contents of chapter number 2, and then in chapter number 2 we did design. We did design of the canal, how to design irrigation canal system, and while designing the irrigation canal system, what are the relevant terms and what are the terms related to the segment of irrigation canal. We talked about all those. We talked about the capacity factor, we talked about the time factor, and also we talked about Leslie's theory and Kennedy's theory, and finally we designed the canal on alluvial soil, unlined canal on alluvial soil, following two theory. One is Kennedy's theory and one is Leslie's theory. And finally, line canal following two specific type of canal. One is circular canal, another one is trapezoidal canal. Depending on the water flow, what type of canal sections we can choose. We discussed about that and we designed a canal. But before the designing of the canal, we should know some other thing that is related to the sediment transport in the river or in the irrigation canal system. Because while we will be transporting irrigation water for the field purpose, for the field irrigation purpose through the irrigation canal, there could have the possibilities of siltation and there could have the possibilities of scouring. So what type of siltation are there in the irrigation water that will be transported by the irrigation canal, and what will be their pattern, how they will be carried, whether they will be settled down or not, if settled down, when and in which condition they will settle down. We need to know all these things, every details, and after knowing how much siltation will be there, and by that way what will be the changes in the cross-sectional areas of irrigation canal, what will be the changes of cross-sectional area of irrigation canal, do we need to have any provision for that purpose? Considering all these things, we need to actually go for designing the irrigation canal. Though we have already designed the irrigation canal, but later we will be talking, today in this chapter we will be talking about the how siltation are carried away through the irrigation canal, how they will be remaining in the suspension or whether they will be depositing on the bed of the canal. All the details related to this, and in which condition, if they are settling down, on which condition they will be settling, we will be coming to know all details. So after knowing all this, then we need to we need to go for designing the irrigation canals, but we have already done the designing part. Now we are entering into knowing about the sediment flow and to know about the flow regime. And today's chapter is on introduction to sediment transport, physical process of sedimentation. So did you understand what I said already? Up to last 5 or 6, 7 minutes. Did you understand?
Yes, sir.
We need to know the physical process of sedimentation, how they will be carrying in the canal. We need to know how they will be remaining in the suspension, or if they will be settling down, in which condition and which favorable condition, how they will be settling down and how much they will be. And because of this settling, what will be the changes in the cross section of canal, irrigation canal. After knowing all these details, then we need to go for the design of the irrigation canal. So we'll be knowing today about the process of physical process of sedimentation, sediment flow, and the flow regime of the canal. Mass of sediment carried per unit time by a channel. What is sediment load? In unit time, how many kgs of sediment being transported or carried in a channel? Carried by two mechanisms. See, this sediment is carried in the channel by two mechanisms. One is bed load, another one is suspended load. The bed load, that is moving forward direction, keeping in touch with the bed of the channel. But suspended load, all the time the sedimentation particles will remain in the suspension or in the water as the suspension. So sediment load is carried by two mechanisms. One is bed load, another one is suspended load. Bed load, grains rolling along the bed with occasional jumps. Basically, all the grains or all the particles will be rolling to move in downstream direction, but sometimes there could have some small jumps for those particles. Primarily, those are the coarse materials, particles of number 4 diameter, number 4 shape. Those will be those will be retaining in number 4 or number 8. Like this type of particle diameters will be just rolling along the bed and having some occasional jumps. Suspended load, these are basically the clay particle or finer materials maintained in suspension by the eddies of flowing water, by the eddy current of flowing water. You might know about this term, eddy current. Suspended load, sediment suspended by fluid turbulence. Sediment remain in suspension by fluid turbulence. Concentration can be substantial in cases of high flows and fine sediment, up to 60% by weight. Vertical distribution. where you can see most of the sedimentation in a flowing water through the irrigation canals. Higher concentration near the bottom of any canal. Coarse fractions concentration decreases rapidly above bed, and fine fraction concentration may nearly more or less uniform from bottom to top of the water table. Fine fractions remain more or less uniform, but coarse fractions remain much more in the bottom side of the canal, and while you are going upward direction, they will be decreasing quickly, rapidly. No theory for concentration at the interface with the bed. Given sediment concentration at one elevation above the bed, it is possible to derive sediment concentration as a function of depth. So sediment concentration, you can consider that one. Depending on the elevation, you can derive a sediment concentration with a function of depth. So you can say that while depth is increasing from the surface of the water, concentration will be increasing. That should have there you can establish a relationship between this. Bed load dependent on sediment size distribution. What is the size of the distribution? The more the size, the bigger the size of the particle, the more will be on the bed. The bed shape. What is the type of the shape of this channel bed? Whether there are any ripples or dunes. Then sediment density, and also shear stress at the bed. Bed load equations. Many researchers have proposed equations. Its equation only applies to the data that was used to obtain the equation. So you can find so many equations, but all the equations are not applicable to all the types. So for a particular type of category, you can use a particular type of equation. So you may depend on the equation, but you need to be careful about the channel characteristics and also what type of equation is obtained because of from what type of experiment. So you need to use those carefully. Bed formation. Variety of bed forms are possible. Bed forms could be different types. Definitely may be of three-dimensional, may vary greatly across the river in the direction of flow. For the river, it can vary. This bed formation can be varied quickly, but in the irrigation canal or this type of smaller canals, it may remain more or less same. Depends on fluid number and effect of roughness. Bed forms result from scour and deposition. So whatever the bed is available today, after few days or after some time, the bed formation may not remain same. Depending on the water flow, and because of their characteristics, there may have scour and there may have deposition, and by that way, bed forms is susceptible to change time to time. Deposition occurs over the crest and scour occurs in the trough. Bed forms are the consequence of instability. Bed forms are the consequences of instability. A small disturbance on an initially flat bed can result in formation of crest and trough. So if there is any type of disturbances because of the high flow velocity, because of any other formation, because of any obstruction, if the bed is initially flat but may change into crest and troughs, and ultimately can be possibilities of having some ripples and dunes there. So just know about the bed forms. The blue color is the water, and the bottom dotted, smaller dotted are the sandy formation of the bed or bed formation. Low velocity, fine sediment, sand wave moves downstream, wavelength less than 15 centimeters. Those are the ripples. But intermediate between ripples and dunes, and possibilities of having huge dunes, huge dunes, and larger and more rounded than ripples. So a perfect dunes you can see at the bottom, and at the surface of the water, you can see the longer waves of the water flowing. So top surfaces of water is not also stable. It is having some wavy patterns. Dunes are eroded at a fruit number close to 1. No reduction in friction factor or max n. It will remain more or less equal. And if more waves are coming, in that case, standing waves in phase with the water waves. Formation of the channel bed of or this will create in accordance with the water wave. And the more will be the swirling on the surface of the water ribbon. Sand waves move upstream wavelengths and having some incipient breaking, or those are called the swirlings. Rip current, channels, and we will be coming to know about how erosion, transportation, deposition, and what will be the formation of sedimentary structures. Sedimentary cycle, how sedimentations are creating and finally going up to the deposition. In between, there will be having some erosion, transportation. So because of the weathering activities, particles will be tracked in the up. If the velocities are more, less the width of the river or less the cross-sectional area, velocity will remain more, and there will be having more erosions. And there you can see the food particles will be in motion direction. Then transport particle will be movement, will mean movement. Whenever the water is coming to the flatter condition, wide river width or channel width, then velocity will be less, and finally it is going into the cycle of deposition, stop particle motion, and ultimately going for the deposition. In which fashion particles normally move? QA, either by entrainment or by transport or flow. Particle moves in downstream direction, either by entrainment way or by transport or flow way. Basic forces acting on particle. What are the forces acting on particle? Because of those, the particles are moving in downstream direction. And those forces are basically the gravity force, drag force, and lift force. Attraction towards the center of the earth. Matter of friction between water and bottom of water channel or particles. Caused by Bernoulli's effect and eddy current or some other way. The lift force are coming from. And those are the forces responsible for the movement of particle by entrainment way. You know this Bernoulli's equation. Three types of energies are equal to remain constant at different sections of a river or flowing channel. Potential energy, kinetic energy, and pressure energy. Pressure on grain decreases, creates lift force. Faster current increases, likelihood that gravity, lift, and drag will be positive, and grain will be picked up, ready to carried away. Grain size, friction, shorting, better roughness, electrostatic attraction, cohesion, and because of all those, this movement is not so simple or so easy. As you can see, these type of forces are getting affected while the particles are about to move. Lift component, Bernoulli's effect, and because of these Bernoulli effects, they could have these eddy currents and other energy, potential energy, kinetic energy, and because of this lift component that created, the direction of flow, there could have the gravitational attraction on particle and a lift. It is against the gravitational acceleration, and there may have some other the dragging force that reduces the flow of the particle because of the water pressure and because of the friction on the bottom of the surface of a river or flowing or a channel. So these are the ultimately the which one will be winning. The particle will behave like that, whether it will be on rest or whether it will be on movement remaining on the bed, or whether the particle will remain in the suspension and move downstream direction. As you know, type of flow, laminar and turbulent. In turbulent, you can see particles everywhere, and flow lines changes constantly, instantly, and all the time because of these eddies or swirls. Why laminar and turbulent? Why the flow are different types? Because of flow velocity, because of the bed roughness, because of type of fluid. If fluid type changes, then flow type of flow also could be changed. More energies are there than flow velocities. Because of flow velocity, we can differentiate the type of flow, whether it is laminar or whether it is turbulent. We can differentiate by to differentiate laminar and turbulent. And depending on the bed roughness, what type of flow will be there. could be decided in the geologically significant fluid flow types, processes, laminar flow and turbulent flow. And laminar straight and or boundary parallel flow lines you can see. But turbulent flows constantly they're changing flow lines. The flow lines are constantly changing. Not much transport in the flow direction. The flow direction could be for each particle, flow direction could be in different direction. Not all the time in the direction of total movement of the fluid. Not necessary. Could be in any direction. Fight between inertial and viscous force. If water wins these fights, then there will be ultimately the flow. Otherwise, stoppage of flow. Inertial and viscous force. Object in motion tends to remain in motion. Then something to stop, that is viscous. So object in motion tends to remain in motion all the time. Slight perturbation in path can have huge effect. And perfectly straight flow lines are rare. Perturbations, I am not sure whether you know this term or not. The smaller roughness could be said as the perturbation. Viscous flow, viscous force. Object flows in laminar fashion. Because of the viscosity, any object in the flow is liable to become in laminar fashion. Viscosity resistance to flow. Viscosity fluid uses so much energy to move, it's more efficient to resist. So flow is generally straight. Low viscosity, like air, very easy to flow, harder to resist, so flow is turbulent. So whether the fluid is viscous, more viscous, basically remain in laminar flow condition, low viscous fluid remain in turbulent. Reynolds number, BL divided by rho by mu. You know this equation. Rho by mu is the kinematic viscosity. Fluids with low nu are turbulent. Change to turbulent are determined experimentally, as we know. Less than 500 is completely and purely laminar flow. And more than 2000 is completely turbulent flow. In between this, any type of situation you can see, depending on the segments of flow in the direction of liquid flow. It is laminar, flowing like laminar, but sometimes there could have some turbulence effect also. So this is more or less a complex situation. So less than 500 Reynolds number is can be said as completely laminar flow, and Reynolds number more than 2000 can be said completely as the in between this is a transitional way. Maybe sometime maybe laminar, sometime maybe turbulent. What else impacts some fluid flow? This fluid flow, what are the impacts for this type of fluid flow? They impact on channels, they impact on water depth, smoothness of the channel surface. Because of this, the fluid flow could be impacted. Channels, different types can be said. Channel type, channel bed, channel roughness, channel width, channel shape, channel situation. All those could impact in fluid flow. Water depth also can impact about fluid flow. Smoothness of channel surfaces can affect on fluid flow. Roughness and a smooth surface of this channel surface could create the fluid flow from turbulent to laminar or laminar to turbulent, and whether there are any viscous soft layer. Channel. So if the channel bed having greater slope, there could have a greater velocity in the water. So ultimately possibilities of having turbulent flow in the channel. Higher velocity will give you the greater lift force. That means you can say that this type of greater slope will give high velocity, and greater slope will give you more chances to be erosive. Greater inertial forces, so higher Reynolds number, and could be the more turbulent. Water flowing over the bottom creates shear stress, so ultimately trying to retard the flow. Shear stress will be highest in contact of surface, decreases of whenever it is moving upward from the channel bed. Velocity lowest at contact surface and increases up. Velocity of the water flow is very low at the contact surface of the channel bed. But if you move upward direction from the channel bed, you can see that velocity of water is increasing. Depth over which friction creates a velocity gradient. Shallow water, entire flow can fall within this interval, and deep water only flow between bed level is retarded. Otherwise, flow is in case of deep water, the flow velocity more or less remain same in total cross-sectional area, but at the bottom level, the flow velocity is bed level restricted. Water depth, boundary shear stress, straight that opposes motion of fluid at bed surface. So from there you will see a particular type of curve. You can see how they will retard the water flow or their characteristics. The resistance to fluid flow across bed, ability to fluid to erode or transport sediment. Boundary shear stress increases directly with the increase in the specific gravity of fluid. Increasing diameter and depth of channel and slope of bed. So depending on these factors, boundary shear stresses could be increased or could be decreased. Moves higher velocity particles closer to the stream bed or channel side. Increases drag and unleashed thus erosion. Turbulence, this flow applies to stream channel walls, not just bed. This is actually same as what we discussed in Kennedy's theory and Lass's theory. Kennedy's theory is saying that the resistance is applicable only the channel bed. But in lattice theory, it is said that not in the channel bed, but also channel wall. So this is very much similar to the lattice theory. Smoothness of the channel bed, whether there will be any obstruction or the water will move smoothly. If there is any obstruction, that will decrease velocity around the object. So a bigger particle or a bigger stone is there at the channel bed. Around that, velocity will decrease. And there it will create the possibilities of creating the turbulence. Viscous sublayer. At the surface, there is a molecular attraction that causes flow to slow down. So whenever you see the flow profile of a channel, then at the surface of the river, at the surface of the channel, the flow is less than the middle side of the channel or river. The flow velocity at the surface of the river and at the bottom of the river is less, and the flow profile is like a curve, a U-shaped curve. So at the surface of the river bed or sorry, river or channel, the velocity of water is less. Also at the bottom of the river, because of the shear stresses retardness, the velocity of water is very less. But middle depth, especially the maximum water flow can be attained at 0.8 from the bed of the channel, 0.75 to 0.8 of total depth of water. As you have seen, entrainment and transport forces acting on particles. You have seen this picture earlier. Inertial forces, that is because of the flow, and including grain immobility, that F1 is gravity, friction, and electrostatics, and FM, fluid drag force, Bernoulli force, and buoyancy. Those are restricting the flow. And ultimately, if Fi is greater, then flow will continue. Deposition occurs when system can no longer support grains. And that time particles settling. Particle cells due to interaction of upwardly directed forces and downwardly directed forces. So upwardly directed forces, as you know, buoyancy force or drag force or Bernoulli's forces. What are the forces? Or because of those are the upwardly directed forces. If these upwardly directed forces is less than gravity force, then all the particles will gradually settle down. Generally, coarser grains settle out first, following Stokes' law. I think you might know about the Stokes' law. When a free-falling particle will lose some of its velocity because of the friction or drag force, but with a uniform velocity, it will move downward direction and ultimately move the channel bed. Turbulence plays a large role in keeping grains aloft. If there is no turbulence, then there will be creating the phenomenon of deposition. Particle settling, you know this equation. This is called the Stokes law, and following this one, ultimately particle will settle, or it will guide whether the particle will remain in the suspension. Increased velocity, increased turbulence, and entrainment. Material also plays a role. Rollstrom curves, you can see this one. This is the empirical measure of minimum velocity required to move particle of different sizes. You can see about this curve. Rollstrom curves, depending on different situation or what are the minimum velocities for a particular type of diameter. This curve will guide you whether it will remain in the suspension or whether it will settle down or not. This curve is basically formed in empirical way after a series of experiments. From that experiments, taking the data, this curve is formed. Series of grain size in straight sided channel, increased velocity until grains move. In experiment, there are different size of particles remain in the water flow, and gradually trying to increasing the velocity as long as the flow is starting movement. And from those experiments, this will curve created. Threshold velocity to entrain particles, transition zone, specific like packing, and intuitive except for class cohesion, electrostatic attraction, and viscous layer. This commonly remain in the suspension because very smaller particle. But for the larger particles or sandy characteristics particles, this Holstrom curves is basically helping you what is the minimum velocity to particle entering into the entrainment or movement. This is basically called the Holstrom diagram. As you can see at the bottom size, you can see different types of names of different types of particles: clay, silt, sand. In the sand, there you can see different types of names of sand: very fine, medium, coarse, very coarse. And then coming the pebbles and cobbles. And understand what is the size ranges for clay, what is the size range for silt, what the size range for sand, and what then coming the pebbles and cobbles are even more 100 diameter. Okay, and you can see velocity in the channel or in the river. Here you can see what type of particle, which size particle will remain in which condition. Either entrainment or in suspension or in consolidator or settle down. Grains in motion. Once the object is set in motion, they will stay in motion. Transport paths. Transport path could be of different types. The transport path could be followed by traction, could be followed by saltation as the bed load or as the suspended load. Grains can shift pathway depending on conditions. So a particle is following traction will not remain in traction all the time. A particle in bed load, moving in bed load direction, will not remain in bed load condition. Depending on the conditions, the pathway transport path could be shifted. So what is traction? Traction is basically the grains rolling or sliding across the bottom. What is saltation? Whenever the grains are hopping or bouncing along the bottom. I think you know the hop, small jumps, hopping like the frog. The small jumps, this is called saltation. And bed load, this is basically a combination of traction and saltation. So traction and saltation is guiding the bed load. A bed load sometimes could be in traction and sometimes could be in saltation. Whenever the particles are moving above of the bed load, then they will remain in the suspension. And ultimately following those upwardly directed forces, I mean the uplift force and gravitational force, depending on those. Uplifted state through turbulent eddies. Plain seals usually can be larger, that means sands in floods. Clays and silts usually remain in suspension, but the larger sands in flood also can remain in suspension float. But in very slow velocities or low velocities, the sands and coarse or fine materials could become as the bed load condition. And there could be moved either like traction or saltation following anyone. So this is the graphical demonstration of traction and saltation, rolling or saltation. These are the type of the bed load movement, and then it is coming as the suspension material. So this is actually the big aspects of showing the Schulstrom curves. From there now you can easily understand what size of diameter of particle will remain in which condition. So think a size of 0.01 diameter, the very low velocities of 0.1 centimeter per second, it will remain in transport in suspension. But if a particle of 0.1 millimeter diameter with a velocity of 0.1 centimeter per second will remain in the deposition. That means the bed load. And whenever, for this particle, if the velocity of flow is increasing, then ultimately from deposition condition to transport in suspension, and then erosion and unconsolidated mud, and then erosion and transport, ultimately moving depending on the increased velocity of the river water. So this is the enlargement of that curve. এই তো So I think I can stop today's class here, not to continue anymore. On Wednesday, I'll take your class once again. So thank you very much.
জনি তাকি
এক দুইজন থাকিস
আরে আমি খেয়াল ছিল না খুইলা দেখি তুই আর বাদ দে বাইরে যাই ওগো ক্লাস শুরু হইতে পারে আবার
আমরা থিসিস নিয়ে আলোচনা করি আর মাইন তো নাই জয়েন
আচ্ছা কি এতজন লেফট মানে এখন লেফট দিতেছে আচ্ছা আগে লেফট
পোলাপান কি
থিসিস
আছে
নিয়ে
নাকি
কি থিসিস নিয়ে এখন কি করবি
না না বললাম
আর ঠিক আছে পরে কথা হবে তাহলে বাই